Alright, today we're going to be talking about the secant function. So, with secant, one thing I want to quickly remind you of is that when we are talking about sine, cosine, and tangent, remember their reciprocal identities would be cosecant, secant, and cotangent. Now, the secant function is what we're going to be focusing on here. So, really, what we're going to do is we're actually going to see how the cosine function relates to the secant function. I think you'll find after spending so much time with sine and cosine that secant and cosecant will not be that bad. Let's go ahead and take a look at the secant function. So what I want you to do is first graph or think about this as just being the cosine of x. So it's reciprocal. So let's go ahead and graph cosine. So remember, cosine starts at the maximum, and then obviously you can't go any higher than the max. So cosine is going to go down from the maximum. I didn't draw the dotted lines, but you could if you wanted to. Now from here, this is our cosine function. I'm trying to round those out as best as I can. Now, how does this relate to the secant function? So as we transition over to the secant function, one thing that we can do is start drawing vertical asymptotes or vertical dotted lines everywhere your sine or cosine, in this case cosine function, crosses the midline. And what's going to happen is you're going to find your min and your max for each area of the sine or cosine function. And we're going to draw, it's not technically a parabola, but we're going to draw a parabolic-like structure here through that min or max. And this that we're drawing here in red is our secant function. So when given secant or cosecant, all you have to do is graph sine or cosine, and from there you'll find the min and the max, and you will draw what looks like a parabola, but it's not, and that would be the secant function. So this is what the graph of secant looks like. So if you could imagine us taking away all of the blue dots here, didn't mean to take the x-axis away, but if we took all the blue dots away, this would be our secant function. Okay, now, what if we continue for a second problem? So again, pretending like this is just 2 times the cosine of x minus pi over 2 minus 1. Let's go ahead and see what we have here. So we have an amplitude of 2. We know that this means we're going to go down 1, so down 1. Our period is 2 pi over b. In this case, b is 1, right? And then this right here is opposite of what you would think. So this actually means we're going to go to the right a distance of pi over 2. Now remember, I will always give you a horizontal transformation that is a tick mark. Let's go ahead and label our tick marks here. So we know our fourth tick mark being 2 pi. Half of that would be 1 pi. Half of that would be pi over 2. And then times 3 is 3 pi over 2. Now we're going to go down 1. So we'll have to make sure we put our dotted line here. Down 1. But our amplitude in this case is 2, meaning that we are going to have to go up a distance of 2. And this will be our maximum. And down a distance of 2. And this will be our minimum. Okay. Because secant is the reciprocal of the cosine function, what we're going to have to do is figure out where does cosine normally start. Well, cosine normally starts at the maximum, so we would normally be at the very top. However, notice that this means that we're going to go to the right a distance of pi over 2. So instead of starting where we normally would on the y-axis, we're going to go a distance right pi over 2. So cosine is going to start here. Because it's at our maximum, every tick mark and every dotted line after that, we're going to follow the same pattern that we have been following. And we're going to connect all these points. Now, this is the cosine function, and we are more worried about the secant function. So for the secant function, now let's find everywhere that this crosses a midline, and we're going to draw an asymptote, a vertical asymptote, at the point where the graph crosses the midline. So in this case, it's the y-axis. Okay, so now, remember, this is our midline. So every point where it crosses the midline, we're going to draw a vertical asymptote. Now we need to find the max and the mins. We're going to just draw our U shape and N shapes everywhere that we have a max and a min. And this, in blue, is technically your secant function. Now, I realize this might be a little bit difficult. It might seem like it takes a lot longer because you're kind of graphing your cosine function first and then using that to find your secant. So it does take a little bit longer, but we will continue to practice in class.